Hey guys, this is Mrs. Lyons. I just wanted to take a couple of minutes with you and go over the homework that you have so that you can check your answers once you have taken a shot at solving these solubility curve or answering these solubility curve questions. Okay, so this is the worksheet that you got in class. And let me just adjust here a little bit. Okay. And then you should have also gotten a full page solubility graph. And I labeled it solubility curve 1. We may use another graph at some point. Hang on to this and I'll refer to it as we go through and practice. All right. Okay. So if we look to answer some questions, what are the customary units of solubility on solubility curves? So this is asking us what are the labels for the axes. Okay, so we have temperature in degrees Celsius, and on our y-axis we have grams of solute dissolved in 100 grams of water. Okay, so that's what that's asking. Define solubility. I'm going to have you look back at your notes and determine that. According to the graph, the solubility of any substance changes as, so what are we graphing? What are we looking at? The solubility changes as the temperature changes. All right. List the substances whose solubility decreases as the temperature increases. Okay, so when we look at that, what this question is asking us is, where are the compounds that have downward or negative slopes? So what are the compounds that our line goes down instead of up? So there are two of them on this graph, NH3 and cerium sulfate. Okay, so I'm going to write this over here. Substances that decrease are NH3 and Ce2SO4 which substance is least affected by temperature change? Okay, so when I ask you that, I'm asking you again to look at the slope, all right? And I'm asking you which of the substances graphed has the least change in the slope, okay? And it's hard to see because it's kind of right here on the 40 gram line, but if you look at sodium chloride, this line barely changes as we go across the graph. So that would be the answer to that question. Sodium chloride is least affected. All right. How many grams of ammonium chloride can dissolve? That's not a good sentence. How many grams of ammonium chloride can dissolve at 50 degrees Celsius? So let's look. Well, here's our line for ammonium chloride. Okay. It asks us at 50 degrees Celsius. So we're going to go from 50 degrees. Let me get a marker. From 50 degrees up here to NH4. So that's right there. All right. So how many grams? 50 grams. Okay. So 50 grams. All right. Blank and blank have the same solubility at 78 degrees. So basically what this is asking us is to look at 78 degrees. And are there two lines that cross? All right, so I'm going to go 78 degrees. I'm going to go up, 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 up. And if I look right here, sodium chloride and potassium chlorate cross. Okay, and where they cross, it means they have the same solubility. All right, so my answer to this is going to be sodium chloride and potassium chlorate, KClO3. All right. Let's see. Which compound is least soluble in water at 10 degrees Celsius? So we talked about this earlier. When it asks us least soluble, we're going to look at the temperature, so 10 degrees, and we're going to look at the first line. The first compound we come to in this case is KClO3, which means KClO3 is least soluble at 10 degrees Celsius. How many grams of KNO3, potassium nitrate, can be dissolved at 50 degrees Celsius? All right, so let's see, 50 degrees. I'm going to go up all the way up to my line for potassium nitrate. I look here and it says 80 grams of potassium nitrate will dissolve at 50 degrees Celsius. Okay, so once you get used to reading this graph, you guys, it's not terrible. It's not bad at all, actually. You just have to remember that the temperature's on the x-axis, grams on the y-axis. Okay, and you've got to read the question, to kind of know what they're asking. So they give us the temperature, they give us the compound, they want to know grams. So 80 grams of KNO3. Make sure you're putting units on these too. All right, 80 grams dissolves at 50 degrees. Are the following solutions saturated, unsaturated, saturated, or supersaturated? Remember, unsaturated is below the line. Saturated is on the line. And supersaturated is above the line. Okay, so 45 grams, 30 degrees Celsius. Now, I've noticed a lot of times you guys are getting tripped up when it says this in 100 grams of water. You can ignore that, because all that's telling you is what our graph says, grams of solute in 100 grams of water. Okay, so this has nothing to do with what we're looking at, where we're looking on the graph. All right, so 45 grams of NaNO3 at 30 degrees Celsius. So 30 degrees Celsius, I'm going to go up to 45 degrees. All right. Oops, hold on. 45 grams. See, this is, you got to see, I get even tripped up. 30 degrees, I had it right. 45 grams would be right about here. We're looking at NaNO3. So NaNO3, the line is way, way above, which makes this unsaturated. And I'm going to abbreviate, just on is fine. All right. 60 grams of KClO3 at 60 degrees. So we need 60 degrees and 60 grams. And we're looking for KClO3, which is right here. So my point, where was it? 60 is all the way up here. KClO3 is down here, so that it's above the line. So that's going to be supersaturated. Okay. So there's a lot of things we can ask you using the solubility graph. It's just important to practice so that you know how to read the questions. All right. Number 11, how many grams of sodium chloride are required to saturate 100 grams of water at 100 degrees? Okay. Once again, this is just telling us what the graph is. We don't pay attention to that. We're looking at sodium chloride at 100 degrees, and we need to know how many grams. So 100 degrees, we need to go up to sodium chloride, which is right here. All right. And I'm going to say, I'm going to be okay with that being right on the line. So at 100 degrees, 40 grams of NaCl will dissolve in 100 grams of water. Yes, 40. So 40 grams. All right. How many grams of NaNO3 are required? So we're looking for grams to saturate 100 grams of water. Again, that doesn't matter. That's what our graph says at 80 degrees. So now we want 80 degrees. We want NaNO3. So I'm going to go all the way up here. Goodness, all the way up here to NaNO3. All right, and then I'm going to read over to the number of grams. I'm going to say about 145 grams. Okay, make sure I did that right. 80 degrees Celsius. I'm looking for NaNO3. So yeah, 145 grams. Okay. How many grams of potassium iodide, Ki, will saturate water at 20 degrees Celsius? So Ki is all the way up here. We're going to look at 20 degrees Celsius. So I'm going to trace this up, all the way up to the top of the graph. And I'm going to say about 146, maybe. So 146 grams. Now, again, these numbers are estimates because you may have said 145. You may have said 147. If you're in the ballpark, you're going to be fine. Okay, I'm not going to be looking specific because this is a graph and we're estimating. All right. All right, number 14. At what temperature would 25 grams of potassium chlorate dissolve? So this is just asking us where do we find a saturated solution of potassium chlorate? So let's see, where is potassium chlorate? Potassium chlorate is all the way down here on the bottom. Okay, so this is our line. And it's asking us 25 grams. So I'm going to go 25. And then I'm going to work my way over to potassium chlorate. And I'm going to say about 60 degrees Celsius is where 25 grams. So 60 degrees Celsius. Make sure you're doing the right answers. This is asking for temperature. So make sure your units are correct. All right. At what temperature would 55 grams of ammonium chloride dissolve? So we're looking for temperature again. It gives us the substance. So it tells us we're looking at ammonium chlorate, NH4Cl, and 55 grams, right? 55 grams. So I got to make sure I'm going over here, 55 grams. So I'm going to go about here, 55, and I'm going to take my line over. I'm going to say about 60 degrees. All right, let's see what's next. 89 grams of NaNO3 is prepared at 30 degrees Celsius. Will all of the salt dissolve? All right, so 85 grams or 89 grams of NaNO3 at 30 degrees Celsius. Lots of information there. So 30 degrees Celsius, we need to go up to 89 degrees, which is going to be about right there. All right, and then what is it asking us? It's asking us NaNO3. So NaNO3, the line is here. So our point is right here. Okay, that's below the line. So what that means is, yes, all of that will dissolve. Okay. And then what mass of NaNO3 would dissolve at this temperature? So it's asking us where is the line? Okay, so 30 degrees up here, I'm going to say about 96 grams would dissolve. All right, so 96 grams. All right. Okay. I need to, sorry, I just missed a phone call and I'm going to. All right. My daughter keeps calling and interrupting. I apologize. At least you know my videos are real and current because I'm always telling you what I'm doing in my other life as not being a teacher. All right, back to our worksheet. Number 17. If 25 grams of NH4Cl is dissolved at 50 degrees Celsius. Okay, so let's find that point first. 25 grams at 50 degrees Celsius. So 50. 10, 25. I'm going to go right about here. It's going to be my point. Okay. Now, what is it asking? how many additional grams would be needed to make the solution saturated at 80 degrees. Good Lord, that's a lot. All right, so it's saying we have 50 grams, or we have 25 grams at 50. We want to raise the temperature to 80 degrees Celsius. So we've still got our 25 grams, but we're going to go over here to 85 degrees Celsius. Okay. And it's asking us how many additional grams would be needed to add to make a saturated solution. So NH4Cl, the line is here. So if my point is right here at 25, I'm going to take the difference. So that would be 5, 15, 25, 35, and I'm going to say about 39 more grams. One way to do this is to say that 25 is dissolved. How much will dissolve? So we would go up here and look. Let's see, that says I'm going to say about 68 grams would dissolve for a value of about 43 grams extra would dissolve. Okay, that makes sense. Yeah, 40. So about 43 more grams will dissolve. And what's interesting, you really didn't even need that first bit of information. All they're really asking is, if you have 25 grams, how much more can you dissolve if it's at 80 degrees Celsius? Okay. All right, number 18. At 50 degrees, how many grams of KNO3 will dissolve? Now we're back to some of the easier questions, the straightforward. At 50 degrees, how much KNO3 will dissolve? 80 grams. Okay, so I just look at 50 degrees, go up KNO3, 80 grams. Did we already answer that question? We did. All right, we're going to answer it again. All right. Number 19, at 70 degrees Celsius, how many grams of cerium 3 sulfate Ce2SO43 will dissolve? So 70 degrees, and we're looking for cerium sulfate, which is right here. I'm going to say maybe 4 grams. Again, if you say 5 grams, it's not going to be wrong because it's an estimate. All right. All right. Determine if each of the following is unsaturated, saturated, or supersaturated. So 55 grams at 20 degrees. So 55 grams at 20 degrees of NH3. So here's the line for NH3. This is below the line. So that's unsaturated. 10 grams of cerium sulfate at 10 degrees. So here's cerium sulfate. 10 degrees, 10 grams would be right here. That's above. Oh, nope, sorry. Cerium sulfate's this line. Okay, so that's below the line. So that's going to be unsaturated. Did I do that first one right? 20 degrees. Back up. I think I messed this one up. I did. See, I do this too. So 55 grams at 20 degrees. So 20 degrees, we're going to go up to 55 grams. So that first one should be supersaturated. Do you see what I did? I switched my grams and my degrees. So don't do that. So this would be supersaturated. All right. That's why it's important not to get distracted while you're doing this. I got distracted by that phone call from my daughter. My ADHD kicked in. And if you are watching these videos and checking my answers, if you ever see a mistake, send me an email. I'll give you a bonus point. All right. If you see an error that I have made. All right. C, 125 grams of potassium nitrate at 60 degrees. So 60 degrees. I want to go all the way up to 125. That's going to be right about there. All right, 60 degrees, 125. We're looking at KNO3. KNO3 is here. This is above the line, so that's going to be supersaturated. 65 grams of ammonium chloride at 80 degrees. So 80 degrees, I need to go up to 60 grams. Okay, so there's my point. What substance am I looking for? NH4Cl. So 80 degrees, 60 grams. NH4Cl is right here. This is the line, the saturation line. Since that is above the line, this is an unsaturated solution. Hold on. Let's double check. 80 degrees, 65 grams. 80 degrees, not 60, 65. So I almost messed up again. That would be a saturated solution because it's right on the line. Okay, so double check that. 80 degrees, 65 grams. 80 degrees, not 60, 65 grams. I'm going to call that on the line, so saturated. Finally, 12 grams at 90 degrees Celsius, and we're looking at NH3. So 90 degrees Celsius, 12 grams. So 10, 12 would be right about here. Here's our line for NH3. So this is above the line. That's going to be supersaturated. All right. Okay. Now I think we get a couple of challenging ones. A saturated solution of KClO3 was made with 300 grams of water. Now, I keep telling you to cross off when it says 100 grams of water, but if it's got a different number of grams of water, that matters. Okay, so we make a saturated solution at 40 degrees Celsius. All right, so let's look at 40 degrees Celsius KClO3 in 100 grams of water. All right, so 40 degrees Celsius here, 40 degrees Celsius, and we want to know how much KClO3 is dissolved. So I'm going to say 10, I'm just going to say about 15 grams. So here's what I'm going to do. I'm going to say 15 grams dissolves in 100 grams of water. This wants to know how much dissolves in 300. So we would have to multiply 100 by 3 to get 300. So we're going to multiply 15 times 3, all right, which would give us 45 grams in 300 grams of water. All right, you're just going to multiply this by whatever amount extra water you have. All right, 500 grams of water was used to make a saturated solution of KClO3 at 10 degrees Celsius. How many grams were dissolved? So this is the same thing. It's asking us, instead of 100 grams, we have 500 grams. Okay, so 10 degrees KClO3. So we're going to look and see how much would dissolve in 100 grams of water. All right, 10 degrees. We're going to go up to here, the line for KClO3. I'm going to say that's about, 14 grams maybe. All right, so I'm going to write that over here. 14 grams dissolves in 100 grams of water. So I want to know how much in 500 grams. So I've got to take this 14 times 5. So what's that going to be? 70, I believe. 5 times 10, yeah, 70 grams of KClO3 in 500 grams of water. All right, couple more. How many grams could be dissolved if the temperature was raised to 100 degrees Celsius? All right, so now we got to do a little thinking. All right, so this started us at 10 degrees. It's saying we want to raise the temperature to 100 degrees. Okay, so basically what we need to look at is 100 degrees Celsius. How much KClO3 will now dissolve? So I'm going to go up here. This is my line. I'm going to say that's about 49 grams in 100 grams. So how much would that be in 500 grams? So let's see. I'm going to to calculate, so if it's 49 in 100 grams of water, I need to take that times 5, would be 245. All right, so it just says how many grams, not how many more grams. So we just want, all we need to calculate is how many grams of KClO3 would dissolve in at 100 degrees in 500 grams of water. All right. All right. Last question. A saturated solution of KNO3 was made with 200 grams of water at 50 degrees Celsius. The solution was cooled to 20 degrees Celsius. How much KNO3 precipitated out? So this is like we've done in our couple of labs where we heat it up, we make a super saturated solution, and then when it cools down, we get that crystallization. So this is first, it's saying in 200 grams of water. Let's figure out what it would be in 100 grams of water. So we make a saturated solution at 50 degrees. All right, so at 50 degrees, KNO3 is right here. So I'm going to write that down. 80 grams of KNO3 will dissolve at was that 50 degrees? Okay. Now, it's saying that it's cooled to 20 degrees Celsius. All right, so now we need to look and see at 20 degrees Celsius how much KNO3 will dissolve in 100 grams of water. So we're going to go up here. Here's the line. So 20 degrees, KNO3 is going to be about, I'm going to say about 32 grams. All right, so 32 grams of KNO3 will dissolve at 20 degrees Celsius. So it's asking us how much precipitates out. So all we're doing is getting the difference. All right. So we're going to do 80 minus 32. So 48 grams would precipitate out in 100 grams of water. It's asking for 200 grams of water. So we just have to double this. That would be 96 grams. All right. That's how much would precipitate out if you lowered the temperature, which is exactly what we did in the lab, except we didn't measure what precipitated out. All right. I hope that kind of helps you understand using a solubility curve and all the different questions that we can ask. I hope you're having a good day. I will see you soon. Take care.